Hi everyone, my name is Pavitra V, Department of Chemistry. Today we are going to discuss a topic called atomic radius. So first we will know what is the atomic radius effect on the periodic table. Distance from the nucleus from an atom to the outermost electron is called atomic radius. It is the distance between outermost electron is nothing but valence electron. The valence electron to nucleus, centrally situated positively charged nucleus. The distance between these two gives you the atomic radius. So it is measured in picometers. This is the atomic size, how actually it is varying in the periodic table. So along the group and along the period, so down the period, the atomic size increases. As the atomic size increases, there will be increase in the atomic radius due to the increase in the atomic number. As we move from left to right, the size of the atom is decreasing, that is, atomic radius decreases due to the attractive force by the nucleus to the valence electron is more, that is, the screening effect is less. So this is the varying of atomic radius or the atomic size along the period and the groups. So next we will move to the periodic trend, that is group trend. As you go down a column, atomic radius increases. In the periodic trend, as you go across a period left to right, the atomic radius decreases. So this is the periodic table changes. Next we will discuss the atomic radius for a molecule, a diatomic molecule. Definition is half of the distance between the nuclei in covalently bonded diatomic molecule. Here we are considering a diatomic molecule, the molecule composed of two atoms, and each atom is situated with a nucleus. So we are calculating the distance between the nucleus of a bonded diatomic molecule which is covalently bonded. Covalent bond is nothing but equal sharing of electrons taking place during the bond formation. So we will get a 2R. We are dividing it by 2. That is, half of the distance is nothing but our atomic radius. So the radius decreases across a period, increased effective nuclear charge due to the decreased shielding, that is screening effect by the middle electrons to the valence electron. The radius increases down the group. Each row on the periodic table adds a shell. Due to the addition of shell, the size of the atom is increases. Hence the atomic radius increases, or the energy levels of the atoms are increasing down the period. So this is the atomic radius. These are some of the metallic radius definition. It is the half of the experimentally determined distance between the nuclei of nearest neighbors in the solid. When we consider the metallic atoms, metal atoms, we will calculate the distance between two adjacent metal atoms nuclei distance. So that is 2Rm. Rm is nothing but metallic radius. Next one is the covalent radius of a non-metallic element is the half of the experimentally determined distance between the nuclei of nearest neighbors in the solid. This we have already discussed. Next one is the ionic radius. Ionic radius of an element is related to the distance between the nuclei of neighboring cation and anions. So we know that anions are negatively charged particles and cations are the positively charged one. The size of the anions are bigger than compared to the size of the cations because the number of electrons are more in anions. Hence it is negatively charged. See, we have discussed metallic radius and covalent radius. There we have mentioned half of the distance. But in ionic radius, it is not a half, it is the total distance, that is r plus r minus. The radius of anion and plus the radius of cation. See, this is one of the example of a problem. Ionic radius of oxygen ion O2 minus is 1.40 angstrom. Angstrom is nothing but 10 power minus 10 meters. What is the ionic radius of Mg2 plus? That is magnesium ion. So we have to measure the MgO bond distance or the atomic radius, and from that we have to subtract the radius of oxygen, that is 1.40 angstrom. We will get the ionic radius of Mg2 plus. So this is an example for a problem. Basic problems they can ask for 2 marks. Next we will move to the van der Waals radius and covalent radius comparison. Van der Waals radius is 1/2 of the distance between the nuclei of 2 atoms in adjacent molecules. But in covalent molecules or a covalent radius, we have considered the distance between the nucleus of same molecule, the atoms situated in the same molecule. But in the van der Waals radius, we are considering the nucleus of 2 atoms of 2 different molecules. This is the difference between covalent radius and van der Waals radius. See, that one is explained in the second point. Covalent radius is 1/2 of the distance between 2 atoms in the same molecule. So van der Waals radius of non-metal is always larger than the corresponding covalent radius. Why it is larger than covalent radius means, in the covalent bond we have the equal sharing of electrons, but in van der Waals it is just a force of attraction between 2 molecules. So attraction may be having a difference or the more length, because of covalent bond is much stronger than van der Waals forces. So this is the difference between van der Waals radius and a covalent radius.